Hey guys, this is our first set of notes from our new workbook, so you need to make sure you have your Unit 3 workbook. And it goes into our new digital notebook. Make sure you put your name on it. And your table of contents you can fill in, page or slide 7 and 8, Radians. Okay, so first thing you want to do is title your paper. Notes 3.1.1 on radians. You don't have to write the essential question. It's on your slides, but at the end we want to be able to answer what 2 units of measurement can you use to measure angles? How do you convert between the two? How can you find an angle using the circle's radius and arc length? Okay, so first off, let's talk about the 2 measurements you can use to measure angles. So you guys probably already know about degrees. That's what you guys have used, I don't know, maybe since middle school you learned how to measure angles in degrees. Well, there's a second measurement you can use, just like you can measure in centimeters or meters, or you can measure in inches and feet. So there's different measurements you can use to measure the same thing. So radians is the measure of, we don't usually use radians, honestly, for triangles. Usually we use them in circles. It's the measure of the central angle that intercepts an arc equal in length to the circle's radius. All right, I'm going to show you guys a visual representation of this using it's called a GIF, right? Okay. So when you're talking about a circle, right, the circle is all points the same distance from the center. The half of the circle's distance, it's called the radius, from the center to the edge of the circle. If you take that radius and lay it onto the circle and connect those endpoints to the center, that's a central angle, and that is equal to 1 radian. As you add 2 radians, 3 radians to complete half of the circle takes exactly pi radians. So go all the way around the circle, 360 degrees takes 2 radians. 2 pi radians, I mean. So we're going to watch it one more time. So one whole circle, 360 degrees, is 2 pi radians. So you can measure in inches or centimeters. You can measure in degrees or radians. So you take your circle, the radius from the circle to the end, center of the circle to the end, you overlap that onto the circle, connect those points to the central angle at the center. That is equal to 1 radian. It's approximately 57 point something degrees. Then if you go halfway around the circle, it takes exactly pi radians, 3.14159 ... Goes on forever. Pi radians is 180 degrees. And then all the way around the circle, 360 degrees is 2 pi radians. Okay? All right, so let's continue with our notes. So the central angle that we're talking about, so if you overlap your radius onto the circle, okay, so to find your central angle in radians, so we don't usually use radians as much in triangles, we will, but usually these radians when we're talking about circles, okay. To find a central angle in radians, you just take your central, the angle that you're trying to find is equal to the arc length divided by the radius. So theta is just, so we'll write theta so you guys know what it's called. Oops, I spelled it wrong. Theta. Theta is just your angle in radians. S is your arc length. And R is your radius. So here is our angle theta, right? If you wanted to find theta, you just have to divide the arc length, which is however long you are on the outside of the circle. That's S. Divide it by the radius, R, and that will give you your angle in radians. All right, last thing that we're going to write down for our notes is converting between radians and degrees. So, you guys can convert between, there's 12 inches and 1 foot. You can convert between the two. So we can go back and forth between radians and degrees. There's just a couple steps. The first step is to set up a proportion. Then you go ahead and cross multiply. And then you just solve for x. So the proportion that you're going to set up is degrees over radians equals 180 over pi. So these two things are equal, 180 and pi, so you put them on top of each other, and then you're converting, you want these two to be the same as well. So you might be given degrees, you might be given radians, you plug in which one you know, so either know degrees or you know radians, you plug in the one that you know, the one that you're trying to find is your x, and then you just cross multiply to solve and for x. So this is a picture we're going to take for our notes, and then we're going to go do 4 examples from our workbook. So you need to grab your workbook, Unit 3, and this is on page 9. All right, your first few homework problems are just finding theta in radians. So example 1 says, given the diagram of circle B, find the measure of theta in radians, round your answer to the nearest 10,000. So 10,000 means, 4 decimal places, because it goes tens, hundreds, thousands, 10,000s. We want 4 decimal places. All right, so we had a little formula. It was theta equals S over R. So S is your arc length and R is your radius. So the first thing that they want us to do, step 1, is find the length of the radius, that's R, and the arc length, that's S. So the radius of the circle is given to you in the diagram. The radius of our circle is 7. The S means the arc length. That is this piece right here on the outside of the circle. It's the arc, and that is 19. So then it says, step 2, substitute R and S into the formula. Theta equals S over R, and solve for theta. So theta equals S is 19, R is 7. I'm going to use my calculator here next to me to divide those two things. 19 divided by 7. I want 4 decimal places, so I get 2.714, and then it goes 28. So the 2 rounds to become a 3, and our units are radians. So what that means is that this radius 7, right? This radius 7 is going to overlap 1, 2, and then 0.7413 or 0.7143 times. So it overlaps once and then twice and then 0.7 whatever. So it's a total of 2.71443 blah blah blah. Okay. So here's R, here's S. So you have a couple homework problems like that. The rest of your homework problems are converting between the two. So example 2 says convert 78 degrees to radians. Give your answer as an exact answer and also a decimal rounded to the nearest 10,000. So the exact answer is going to have the symbol pi, and then the rounded answer is going to be a decimal. Okay, so what you want to do is set up your proportion. The proportion is degrees over radians equals 180 over pi. Okay, so that's what you need to remember. So we are given 78 degrees. So that's what we're going to plug in here. We're going to plug in 78 degrees over, we're trying to find radians, so that's our x, equals 180 over pi. Okay, so you're given degrees, that's one you plug in, x is what you're trying to find, which is radians. And then we're going to cross multiply. So I'm just going to start with x, so the x is on the left. X times 180 is just 180x. 78 times pi is 78 pi, and you set them equal to each other. And then you're going to solve for x. So to get x by itself, I'm going to divide by 180 on both sides. I get x equals, this can be simplified, 78 pi over 180. These can both be divided by 6. So 78 pi divided by 6 is 13 pi, and then 180 divided by 6 is 30. So this is the exact answer. Oh, there's units on this. This would be radians. Then we want to find the decimal answer. When you use the decimal answer, you do not want to use pi as 3.14. You're not going to plug in 3.14 as pi. You want to use pi symbol, so it'd be 13 pi. There's a pi symbol when you're using Desmos, or there's a pi symbol on your iPhone or any graphing calculator, scientific calculator. So we want 4 decimal places, 1.3613. After the 3 is a 5, so that means we're going to round up. So it was 1. Oops, still on my highlighter. 1.3614 radians. This is the decimal. So the decimal is not exact, it's rounded. Okay. All right. So for example, 3 and 4, both of these are given to you in radians, and they want you to convert it to degrees. The example number 3, I'm going to show you guys like a shortcut when you're going from radians to degrees. We know that we're trying to convert 2 pi over 3. Well, this pi right here, we should know that pi is equal to 180 degrees. So that's when you want to commit to memory, is to know that pi, my pen's not working very good. Oh no. Pi is equal to 180 degrees. Oh my goodness, my pen. What's going on? 180 degrees. So we just have to plug in 2 times 180 divided by 3, and we can just solve for our answer that way. So 2 times 180 is 360. 360 divided by 3 is 120 degrees. So if they give it to you as an exact value, 2 pi over 3, you can just plug in pi as 180 degrees and solve it that way. So that one's like a shortcut, so you don't have to do the whole proportion thing, but you could just set up the proportion. For example number 4, it's the same. You're converting radians to degrees, but this one gives it to you as a decimal, not as an exact value. So you can't use that little trick that I just showed you. Instead, you do have to set up the proportion. Degrees over radians equals 180 over pi. Since they gave me radians, that's what I'm going to plug in here for radians. Degrees is what I'm trying to find, so I'm going to go ahead and put that as my x. So I'm going to go ahead and solve. I'm going to multiply. I always just start with x. So x times pi is just pi x equals 180 times 0.5793. I'm going to use my calculator for that. So my calculator, I type in 180 times 0.5793. I get 104.274. And then the last thing I have to do is solve for x. So I'm going to divide both sides by pi. I get x by itself. I'm going to write myself like a little reminder right here. Use pi button, not 3.14. So in my calculator, I divide that by pi. If you turn your iPhone sideways, you can get the pi button. Unless you have the lock on, mine won't lock. Okay. So in my Desmos calculator, I can do it 104.274 divided by pi, and I get 33.19. The problem says to round to the nearest tenth. That's 1 decimal place. So there's a 1 right there. And then you look at what's after it. There's a 9. So you have to round up. So 33.2. These are in degrees. So that's my answer. Okay, so again, to convert between the two, you can set up the proportion. Degrees over radians equals 180 over pi. If they give you degrees, you put that on top and then just make your radians x. If they give you radians, you put that on the bottom and put x on top for the degrees. Cross multiply and solve. Just make sure you use the pi button on your calculator. And if they give it to you originally in Radians with the pi there, you can just plug in 1/80 as pi. All right, so let's talk about where this goes in your notebook. You want to put the notes that we took on slide 7. There's nothing that goes on the right-hand side. We didn't write that much down. And then on slide number 8, instead of showing pictures, I just wrote exactly what page numbers goes on there. So hopefully that's easier for you guys to put these into your digital notebook. So that goes on slide number 8, tells you exactly what pages to go. And then your homework tonight, I think, is page 13, 1 through 10. Show all of your work, and that's it.